This conference.
Yeah, so let's start. Let's continue from like yesterday we were having an overall overview of what we will cover and all. So today it's our day one. So we will start with our sessions. Let me share my screen. I hope my screen is visible to all. Right. So now when we are doing chaos engineering or when we are just beginning into this, like if you are very new to chaos engineering, so this question comes into our mind, like and the major question which comes into our mind is like so many testing practices are there. So why again chaos, right? Like why we need chaos and how the this chaos engineering field came into existence, or we can say like what are the major things which we do in chaos. So that questions like that boundaries we will define properly. Okay, so that's what we will see now. So if we speak about the rise of chaos engineering, now mainly the rise happened due to the complex distributed systems. Now to understand what like for those who are new to distributed systems, just to give you an overview.
Yeah, hi Vishnu.
Yeah, hi.
So, before going to the any project, any application to the live, so we can do perform testing and we can sort it out all the issues, right? Like response times and any server issues, any client side metrics and all. So, and if everything is okay, then we can go to the live
Right.
project. So, but here, what is the objective of by using QoS engineering?
Yeah,
So,
we
any
will understand.
all
No,
Yeah, all
let's
metrics we can cover in performance test. Yeah,
Yeah, so we will cover. Okay, like it's like jumping very far. So let's go step by step. You'll
okay.
understand that soon, because otherwise it will be like a jump. So we will soon answer those questions. Okay, so that's what we are
Yeah,
going into now. Yeah.
yeah.
Okay, so just to understand what's a distributed system for those who are new to this. See now, generally now, initially the systems which we had, like for example, let's take an e-commerce store. Okay, like we had an e-commerce application. Take it any Amazon or Flipkart any store. Now that's e-commerce store. If we divide the functionalities, okay, let's say it has ordering functionality, it has payment functionality, it has let's say catalog where the catalog of the products are there. Okay, that functionality is there. Then let's say it has maybe sign in the login functionality that, or I will say rather than okay login. Let's keep it login functionality. So let's say these are the functionalities. Now this further could be divided, like maybe order will have further like checkout, then into some other y z, so different functionalities. Okay, then this payment could be again x y some other x1 y1, then catalog again to x2 y2. Okay, some other further it's getting divided, like we have just grouped these functionalities into order, these into payments, so that way we have grouped. Okay, but initially where before the advent of distributed systems or let's say services, what used to happen is, now this whenever like let's say now you have order payment catalog and login. Okay, so let's say now this one, uh, let's say order Krishna is working on. Okay, he's the developer of orders. Now payments, let's say Kiran, and let's say catalog again Veera. Okay, and yeah, so now Krishna is developing his code on orders. Now Kiran is developing her code on the payments, and Veera is developing code on the catalog. Now what happens is, now Krishna needs to know what Veera and Kiran is doing, okay? Because otherwise he won't be able to develop the code because they are all interdependent on each other. Okay, so the code like the classes or the objects or what they are using, he needs to know. Krishna needs to know. So unless, so if you see the order, so obviously without login, you cannot develop payments or order because or login is like a basic functionality. It starts from there. Like let's assume. So now unless Veera doesn't completes his development, Krishna and Kiran have to wait. Okay, so that was a very heavy dependency on each other. Okay, so to solve this thing, right, what happened is two things happened. One is we had to solve the dependencies because the dependency, if you divide, there are two dependencies. One is the resource dependency, basically the machines, the CPU, RAM, okay, that dependency. Second is a code dependency like the functions, classes, all those. Okay, so now this resource and code, these were the two dependencies which we had. Okay, so to solve this two for problems, we there came distributed systems. Now, what do we mean by distributed systems in general is, so if we take the same functionalities what we had there, like order, payment, and login. Now in distributed systems, first let's solve the problem of code, okay, like the code dependency. So what happened was, now this order, payment, and login. So the main problem, the fundamental issue here is that order needs to know what all data or what all parameters it will get from payments and login. Okay, so that's a fundamental thing or fundamental problem. So unless they don't develop this, we order doesn't know what are those parameters. Okay, so that's the problem we need to solve. So to solve this problem, there came concept of API. So what happened was how the development or the architects solve this issue is by introducing a concept like APIs. So where APIs are nothing but a interface between these different I will not call the word services now, okay, but between these functionalities, okay, or the group of functionalities, and each functionalities what they did is they named it as services. So that's where the microservices concepts came into picture. So microservices are nothing but they are independent entities, okay, they work independently and they interact with each other using APIs. Okay, so now what happened? Okay, let's assume we have an API. So now I know the API definition. I know what will come in the API, what the parameters will be shared by payments to orders, by login to order. Now, so there's no dependency as such, like order needs to wait for payment or login to complete, because what now the order developer can, he can start developing his code based on the API which he will get, right? And later on, even he can create some mocks and all to test his development. Okay, so once the integration is complete, the code can be tested. Okay, so like whether it's working everything properly or not. So this way the code dependency was resolved, and that led to the concept of microservices. Okay, so microservices are nothing but they are independent entities. So what happens is with the advent of microservices, development became independent, deployment became independent. So a lot of things became independent. So now with this, what happened? We now, okay, the code has become independent, right? Like we don't have any dependency between the teams. So teams could also be like what happened was the teams also could be divided into services like order team, accounts team, that way. And with that, what also happened was, now the order team, let's say order team is Krishna's team, right? They are good at Go programming. Okay. Now Kiran team is good at Java, or and let's say Veera's team is good at, let's say some other language. Okay, Python. So what they do with this independency, there is no dependency, right? Because the API has a single language which is common between all, right? But the code which for each services, what Veera, Krishna, they could do is they could have it all different. Like they had their own choices. They can go with Go programming, Java, based on their expertise, right? So what happened was each services had different types of coding language, different types of components. Like even DB, they could choose different. Like let's say Kiran thought, okay, DynamoDB is good for her, good for him, and Krishna thought, okay, the Go programming and with MySQL is good for their team. So things were like every service had different components, different coding, and so though the dependency between each team got reduced, but the complexity increased. Okay, that we need to keep in mind, because as a tester, though there was no dependence, like when we think it as separately, it was like the things became very simple. Okay, but when we thought it as all together, okay, things became complex. Okay, so this thing we keep in mind. Okay, now this is one. Now, okay, so code dependency is done. We are able to deploy fast, develop fast. Teams could adapt new technologies very fast. Okay, so now the only dependencies next one is the resource dependency, which we need to resolve. So resource dependency means like what happened. So now everything is independent. So why can't we keep the resources also independent? So what happened? Like if now we have four services, we kept all four services in different machines. Well, let's say I'm saying like CPUs. Okay, let's assume I'm keeping it on different CPUs. So what happened? Even deployment was also easy, because I could deploy my code into different machines. So when one code is getting deployed, the other doesn't get affected because we are not touching those. Okay, so those way also the resource dependency also was removed. Then further, what happened? Why can't we use the same machine and divide it into further? Okay, so there came the advent of pods and all. Okay, which we will learn as we progress. Okay, what are pods, what are containers, when we go into those sections. So this way, what happened was now both resource and code dependency got resolved, and this whole structure of or the whole working of the application type of working is called distributed systems. Now further, okay, again divisions went on happening. Like again, people what they did, they divided the zones, like based on the country or based on the users, they divided their infrastructure. Again, what happened, this was one zone, there was multiple zones like that. Then this further zones had multiple clusters. Okay, so divisions went on happening, and whole of this became the distributed systems. Like the systems were distributed, that's the meaning of uh, the distributed systems. So any questions, anyone, related to distributed systems? Are you getting an idea what it is now? Right. Okay. So now, obviously, we had an interface to develop. Now that important word, complex, right? That came into picture. Now, what? Why the systems became complex? Anyone? Can anyone? Like why? Why am I saying that systems became complex?
So because too many microservices at many regions and
Exactly.
too many
Mhm.
teams are working on various things, so there's no
Exactly.
single accountability.
Correct. So see now what happened. Now one is working on Go, one is working on Python, one is working on some other. Now they all get integrated together and they all communicate with each other. So the problems which could come up is not very direct. It could be indirect, like the configurations issues or the what we or the system parameters issues. So different issues could come up, and that's what people observed also. Like though they were testing everything, like performance they were doing, functional they were doing, but still there were outages happening, incidents happening in the production. Okay, so for that they came up with a solution that whatever available, because obviously see now what all systems we had previously, okay, we are gone with, like we are done with that. Okay, so how can we stick to the testing? Also we need to have some extra, like different type of testing, right? Because of that new so it's not like okay, we have changed our it's more sort of like we have changed our so, just a minute. Yeah. So we have changed our development practices or systems and all. Okay. But we are not changing our testing practice. It doesn't happen like that, right? If we have changed our development practices so much, right? The distributed systems are so complex, then how can we say that with the traditional testing practices alone, we will be able to uncover all the issues? So with this only, there came different types of testing like chaos engineering, failover testing. Okay, all those came into picture with this or the disaster recovery testing and all, right, all came into picture based on this complexity of the system only. And what people observed also, it's the same thing, right? Like what initially happened was in Netflix, right? um, Now when they were moving on to cloud, so cloud is again a complexity which gets added. Though people think cloud is a very good thing, it makes our things flexible, but that's on the cost side, okay, the commercially. But if you see the complexity which cloud brings in, it's a different story, because it's not that easy to deploy a application to cloud and all compared to monolithic systems. Okay, so cloud is complex. So now again, due to cloud also things became complex. So when Netflix was moving on to cloud, like they were moving on to AWS, what they observed was uh, they were doing all sorts of testing, but still there were issues happening in production, and that was very frequent. Okay, like it was not that it was happening in just it's few times and it's not repeating, but they were repeating also the issues. Okay, so what they thought, like they brought up the solution is, so initially what they were seeing mainly was their systems or the instances, or we can say the CPUs were crashing more. Okay, so they came up with a tool called Chaos Monkey to test that. Okay, so now based on this, new issues came up. So they kept creating new tools like Chaos Com, Chaos Gorilla, different tools. Okay, so that's how the chaos engineering really came into picture. Okay, Netflix were the first organization who started doing chaos engineering. Now this Chaos Monkey, what they did, they used it for some time. Now after that, what they did, they put that Chaos Monkey into GitHub so that others can also use it, like open source. The code, okay, the Chaos Monkey code, they put it into GitHub, and that made a very major change, because it was now the code was accessible to all the organizations, so they all started implementing this in one or the other way. Okay, though in a small way. So yeah, so that way what happened was chaos engineering became like a mainstream activity in most of the organizations. And then what happened was Chaos Monkey was like the person who was working in Netflix chaos team. He started Gremlin. Like he was from the Chaos Monkey team only, so he started Gremlin, and with the advent of Gremlin, chaos engineering became little bit in the mainstream, because there came a paid tool to do this activity. Now it is in a like a burning state, like it's slowly catching up the market. Okay, so that's how the chaos engineering, if you see the rise of chaos engineering, we can put it in a nutshell. Okay, so the main factor which led to rise of chaos engineering is, one is the distributed systems, which we understood now. The second is cloud and the microservices architecture and all those complexities. And obviously what people understood is that the outages are very expensive. So if you have an outage, it's not only the money which you lose, or the uh, it's also the customer goodwill. Okay, so because let's say you are a organization like Amazon, and your application is crashing, okay, and your user is ordering something. When that is happening, now that if when that is happening, now the user is losing his like the he has some trust on the brand. Okay, like so the brand trust doesn't come only from what they do, but also from the technologies and the user experience, what they experience and all. Okay, so what they will do, they will leave Amazon and go to Flipkart, so which shouldn't happen, which is a very dangerous situation. the though the order wasn't placed, that's one situation, but the losing a user for lifetime is a different situation, and which is very much far more a loss for organization. So that is what we target on, like to reduce the outages, to reduce the incidents. The system should recover very fast, that even your customer shouldn't understand that there was a failure. Okay, so those sort of things are mainly focused in chaos engineering, and we try to resolve it. And obviously it's like a vaccine. Now when I say vaccine, let's say, what's the difference between a medicine and a vaccine? Anyone? Like when I say a medicine.
Medicine,
Vaccine is preventive.
yeah.
Exactly. Okay. So vaccine is more sort of a preventive measure. Medicine is like it's a cure, right? So chaos engineering is more sort of like a vaccine. Okay. Vaccine means like before something happens, we need to stop it. Okay, and before an outage happens or before an incident happens, we need to stop it. So chaos engineering is also like a vaccine for our system, for our complex system, where we inject a virus. So how do we generally create a vaccine? Like when the vaccine is getting developed, right? How the testing happens on a human body or some animals, or what do you think?
A small part of the virus that has very
Exactly,
low strength, and
exactly,
then let's
right.
see how it reacts.
Correct. So basically, what happens is when you are developing a vaccine, the virus which you have, right, like for which the vaccine is getting developed, there are different ways of doing that vaccine. I'm just saying a very common way. So what they do is they will, if you have a virus, like let's say coronavirus or something. Now let's say the live virus power is 100%. Okay. What we will do is we will inject a virus into the human body with let's say 50% power. Like the virus will have only 50% of energy left. Okay, so what this injection will do is once that virus enters our body, the white blood cells, or WBCs we call, in our blood, they will, what they will do, they will kill those virus, they will study that virus, and now when this 100% power virus will come into our body, already WBCs know how to kill or attack the virus, what is the weak point of that virus. So that's how the vaccine is generally. So vaccine is actually having a partially potent import, like we can say potent virus. So the vaccine has virus in it, so we are injecting the virus. So similarly in chaos engineering also, we are injecting the failures to study how the system will respond. So now initially when I inject the failure, though it is not that much that much of a higher impact as it happens in production, but I will be able to study my system and be ready when that major issue will happen. Okay, so how my system will respond, how the system will recover, and those things we will study. So that's why it's more sort of the process is more sort of developing like a vaccine for a system. Okay, right. So yeah, obviously, history, if we see when Netflix started, then as I said, Chaos Monkey, Chaos Kong, Chaos Gorilla, all those, they together call it a simian army. That tools all together was called a simian army. And they pushed Chaos Monkey onto GitHub, and rest is history, like what happened. So Gremlin came into picture, right? Right. So now the main question of what is chaos engineering, right? This question we need to answer. Okay. So before we go into definitions, let's try to understand it very simply. Okay, like what it is. Now there is a system. Okay, let's say I have uh, let's say just let's say Amazon is there. Okay. Now this is the front page of Amazon. Okay. Now you are seeing this sign in here. You have the lot of items, like you can order this, you can order laptop and all. You have a search here. Okay. So similarly, you have the cart here. So basically, now if you see in this front page itself, how many services you are seeing? Can anyone? Like, are you seeing only one service in the front page, or are you seeing multiple services?
Multiple
Multiple.
services.
Multiple.
Exactly, right? We have card, we have sign
Catalog.
in here. That's account service. This is a card, like card. Let's say maybe if they have put it in the order service itself, it could be the same order service. But let's say card service is there. Then even search might be different service what they are using based on the complexity of the service. Again, catalog. See, so many products are appearing in front of you. That is coming from catalog, right? So let's say for some case, okay, for due to some issue, if my catalog fails, okay, what will you see in this front page? Like, will the front page load, or like, so these are like the case, okay, like for example, the catalog is not passed, like the catalog service is down. Okay, it's not, we are not able to access the service now. So what will, when a person is loading amazon.in, what he will see, like whether he will see like these images or these catalog things have disappeared, he will see only the cart and account, only those he will see. Let's say, is that the case, or the whole front end or the landing page will not load. What will be the case?
If they are using microservices, in that case, only that part will not be visible.
Exactly. Okay, so that's the beauty of microservices. It's like if at all your services fail, only those services will get affected. The other services will still be intact. So, for example, now if the user comes, though he opens the landing page, he won't be see the other things, but at least he will be able to go to the accounts and maybe see his address and all, maybe update some card details, all those things. He will be still able to do. Okay, so that's the again a beauty of microservices. We need to understand. So all these things will become blank because these are all coming from catalog service, right? These requests, these things. So those things all you will see it like blank. Okay. So when we deploy our real application, you'll be able to see that. Currently, we haven't deployed that. So just wanted to give this as an example. Okay. Now this is Amazon. Okay. So let's take this example. Now, so let's say catalog is failing. Okay, that's the example which we took. Now the catalog is failing and it is taking around 5 minutes to come up. Come up means like automatically it is recovering. Like we have a Kubernetes cluster and we have set up some healing mechanism or a recovery mechanism where it is coming up in 5 minutes. So what will happen for 5 minutes? The front page, whoever will load, they will all see the catalog is not like nothing they are seeing. Okay, so now let's say this is amazon.in, I don't see anything. So what user will think, okay, let me reload it again. So he will reload it. Okay, so again when he reloads it also he will not see it. So that's basically a problematic situation, okay, which we need to handle. So for that, those are the things which we are trying to resolve as a chaos engineer. The recovery, right? How fast my system is recovering. Like this 5 minutes okay, or like if it's an e-commerce store, it should be 10 seconds, not more than that, let's say. Okay, so if let's say it's a banking thing, okay, like a banking application, let's say 5 minutes is okay because it's a banking application. People will not like leave you and go suddenly. Okay, they will reload it, they will log out and sign in again. Maybe the business case itself is a different case there, but for an e-commerce, even 10 seconds is a very huge value for recovery. Okay, so that comes from the SLAs, like what recovery time you're expecting. So we need to discuss with the architects, we come up with the value for each services and different, because even it's not about services, right? Because each service have different components also. Like let's say your DB goes down, your DB service is down. How much time the DB will take to come up again? Like 5 seconds to heal properly again. Okay, and the timeouts, like due to this the timeouts are they increasing because one service is down. So due to that, is there a cascading failure, and that is that cascading failure leading to other issues. So it's the chaos engineering is all about that. Okay, so mainly chaos engineering, if you see, it's focusing on two things. Okay, one is the recovery, how fast your system is able to recover. Okay, that is one thing. And second is the user experience, which generally people don't say directly, but we also have we worry about this because when we improve the recovery of our system, like we make our system faster in recovery, obviously the user experience indirectly will improve. And also there are some other ways to improve the user experience. So now, for example, the same Amazon which I said, uh, now catalog is not loading, right? So when the person reloads and let's say my catalog is still not up, what I can do is when the person reloads, I can redirect the user to some other page where I can keep that user busy with some other task, like let's say some form or something where the user will be still in my application. And once my application or the catalog is up again, I can bring him back to my application. So that way, what I'm doing is I'm just improving my user experience, the experience what the user is experiencing from my application. That okay, like we are not directly showing off our problem to them. Okay, we are just trying to hide our problem. We resolve our problem and then we show the application again to them. So that way we are also trying to make our systems more well in the user goodwill side. Okay, so yeah, so basically these are the things you need to remember when we say chaos engineering. We are mainly interested into the recovery and the user experience. It is more sort of in performance we say load and stability, right? So these are the two keywords when we speak about chaos engineering. Okay, and
Vishnu, I have a question.
yeah, right, good.
Yeah, one thing is like we are using like we are thinking talking about microservices, right? So we already have some recovery mechanisms like circuit breaker or bulkhead. So
Uh-huh.
how would chaos engineering explicitly contribute in front of recovery? So from this
Yeah,
perspective,
so
can you
yeah,
please?
it's a very direct question, right? Like direct answer. So see, now if I say it's recovering in 5 minutes, but who certified this 5 minutes, right? Did anyone certify it? That's first question. Okay, like if someone say it will recover in 5 minutes, like it's more sort of architect saying like my application will respond in 5 seconds response time, but still we are testing it, right? We are
Okay,
certifying that okay, the application will load in 5 seconds, right? So it's more sort of that. That is one thing. Second thing is obviously, see the recovery time, right? It is very much dependent on other factors. It's not like very straightforward. Though we know our system will recover, but in how much time, right? That's a very much of a blank space, a filling the blanks. Many don't know that. You're getting my point, Nandan? So these are the
yeah.
main two things, right, which you will uncover, okay, from the issues. And also, this is also not that straightforward that you can recreate these issues using other technologies. It's very hard to recreate some recovery mechanisms, and that's what we do in chaos engineering.
Okay. So,
Mhm.
just I want to say something like, correct me if I'm wrong. So,
Yeah.
from a
Mhm.
performance standpoint, so what we'll do is like we'll try to identify bottlenecks with respect to resources mostly.
Yeah.
So with chaos engineering, we are trying to identify if there is any sort of gaps in the recovery mechanism.
Exactly. So again, bottlenecks, right? Same thing. Like when we say gaps in recovery, so see, when a system is recovering, but there could be some situations where some other system will block that recovery, or when there are two or three services recovering together, one service will not recover, the other two will recover. So we need to understand what the problem could be, the queuing service, or the problem could be the APIs, right? Or some threads which are active, some processes which are active. So the problems could come from anywhere.
Okay,
I
understood.
hope you're
Yeah.
good. Yeah, right. So those are our area. So the focus is recovery, but we will try to resolve any issues which will come in the path of recovery. We will find that issue, we will resolve it. Okay. I hope I'm clear, Nandan.
Yes, yes.
Yeah,
Got
great.
you.
Any other questions, anyone? Mahesh, I see you here on unmute. Right.
Vishnu,
Yeah,
I
go
have
ahead.
one question.
Yeah.
So this is regarding the how do we assess the requirement for chaos engineering? How do we go about it?
Yeah.
Suppose
So
if
that
there
we
is
will.
a
Yeah, again, it's a little bit of a long jump. We will soon, when
okay,
we cover test plan, right? Test planning,
okay,
and yeah, that time we will discuss that.
okay, yeah.
So no worries, everything we are covering, like I will cover from the starting to the end, what you will require as a very, uh, like an implementation stage itself. Okay, so that it's not that like we are covering which is already there in your organization and we are doing it. It's more sort of you don't have it in your organization and you're doing it. So I will be covering everything in that sense only. So no worries, everything will be covered. Okay, so let's move on. So now we know in a basic level what is chaos engineering, and as we progress we will learn more on this, and that time it will be more clearer when we see the use cases and all. So like what we where to target and what to do and all. So so if I see the if we say chaos engineering, now see, these 3 points are very important. The definition you can forget because it's little complicated definition, and it's hard to understand in this way. So what I said, the simple way, the recovery and user experience, you can focus on those in that way. It will be more clear for you. Okay. Now to coming to the last 4 points, which is very important. Okay. Now chaos engineering is a controlled and again what we do is we do a controlled and planned experiments. So why am I specifically focusing on the word controlled and planned? Can the experiments be unplanned? What do you think? because the
No, if it
name
is unplanned, so then it will be more chaotic.
exactly. So see, when the word comes chaos in your mind, okay, you feel okay, everything is unplanned, random, and all those, right? But do you think chaos engineering is about not planned, or it's not, it's a random thing? What do you think?
No, it's a planned thing. We need to
Because
have support also in place.
exactly. So it's a planned because see, there are two things. One is before, like when we are doing the experiment, and after, right? So this is the boundary where we do the experiment, let's say. So we are now currently we are speaking about this area. Okay, this area means like when we see after we do the experiment, many things what you see in the system will be maybe random issues you might uncover. Uh, so that is a randomness. But here you have a proper plan. It's not random. Like I just go and do some attack and see what my system will do. No, it's not like that. I have a clear objective of what I am doing. Like let's say if I'm injecting a latency, so from that latency, what am I trying to observe? Okay, or what component I am trying to observe? What is my scope? So those things are properly planned and also controlled. Control means like if I'm attacking order service, I should not just go and attack accounts also. So it has to be controlled. Like I should know the scope of the experiment what I'm doing. So because with that only I can get the required resources like the point of contacts, the required data or required baseline metrics, all those. Okay, if I know the scope, I should have a proper control on what I'm doing. Okay, so that's where we say it's a controlled and planned. Okay, that we should keep in mind. Then preparing for unpredictable failure, obviously. Um, that's all chaos engineering is all about. We prepare for the unpredictable failures. Then preparing engineers for failures, that is also there, because what we do is generally it's more sort of like a training event, right? So if you are doing some incident, you are showing, okay, it's more sort of you're replicating a production issue. What will happen is you also indirectly train your engineers, like if this issue happens, who has to respond, how he has to respond, what has to be the chain of events, chain of command, okay, how it should go. So those things you can easily train your engineers on. If this issue happens, what they need to do. And obviously preparing for game days, which we will discuss. What's a game day? That time it will be more clear to you. So game days are nothing but the day when you run test in production, like when you do experiments in production. Okay, so this question always comes into everyone's mind, like chaos engineering is all about production. No, now the chaos engineering is not every time always about production. We do chaos engineering on lower environments first, and then we move on to production. Okay, there's a procedure for that that we will see as we progress. Okay, how we do that. And generally some nowadays in some organizations even they don't do chaos engineering on production. They do it only on the lower environments and pre-prod if at all they have. Okay, so that's how things happen. So that we will discuss how it happens when we go to the next sections. We will discuss. Okay, so let's come to some, like let's see something in action, okay, before we move on to some other more theory. So what I will do, right, let me open AWS. If anyone has any questions, please ask. Okay,
Vishnu, I have a question.
yeah, go ahead.
So, how do we actually mature in chaos engineering? Like, is it a step-by-step approach or directly, like, I'm trying to understand, like, how it would be like. It's just like performance testing setup and random testing. What are the flows which we are doing, right? Like regression or something. So, is it the similar sort of thing, or is it like a uh, what we say a phased approach, or how would it be? Because the implementations also need to be there, right? So you told about recovery mechanism, how fast it is recovering, right? So the implementation mechanisms also need to be there for that recovery to come down to whatever SLA we are targeting, right? So how do we do it? That
Yeah, right. So see, as I said, now chaos engineering is more onto the distributed systems, the complexity of a system. Obviously, now if you have an application which doesn't have such functionalities like recovery or like let's say it doesn't have a self-healing mechanism and all those, then obviously chaos engineering will not play much of a role there, right? You cannot apply chaos engineering there. So that's where we come into picture. Like chaos engineering mainly plays a role where you have such mechanisms in place already. Now that's regarding the application. Now coming to what you do. See, now performance, as you said, the example, performance testing, performance engineering. These are two things, different things. No one starts with performance engineering. They start with performance testing, right? Similar to the same way in chaos engineering also, initially when a person starts, he never goes into a stage where he provides recommendations. Okay, that comes after a good amount of experience. In that experience, what do I mean is the application experience, because whatever application you are testing or whatever application you are experimenting, you need to know it in and out. Okay, then only you can give the recommendations. So what generally happens at the initial stages is you implement the tool. Okay, if or you take some help from someone if you are very new to the application and you don't know how like the application is very complex and you don't know how to deploy the tools like which we are seeing currently in our course. Okay, now if that implementation you are not aware because or the application is very complex, it's on let's say some other very different service or different cloud and you don't know how to do it, so you take the help from someone. But obviously you will know how to deploy it. It's not very hard to deploy any chaos application. It's very easy, which that's what we will see in this course. Now once you do that, what you will do is you will run the experiments. Okay, like you do performance tests, right? Once you run the experiments, recommendations obviously you cannot do in the initial stages if you're not good at the application. So what you do is you send out the report. Okay, this is what the observations are, this is what we observed, so we need to improve these values, right? So that's the initial stages you will work on. Then later on you will also find the problem why that values are that. Okay, and you will provide the recommendations. Okay, change the configuration to this, that will improve our system further. Clear? Am I making it
Okay,
clear?
okay.
Yeah,
Yes, yes, I got you.
right.
So, okay, can we consider like normally in like in our cloud environment we do auto scaling and things. So, can we consider that also some part of chaos engineering recovery kind of thing, or
So
no?
see, one thing, one clear border we need to put. See, there is some mechanism in place, and that mechanism needs to be tested, right? It's a two things. See, auto scaling is though it's there in our system, but still whether the auto scaling is behaving as expected, that we don't know, right? Unless we don't test it. Even dependent services, whether they are clearly performing as expected, we don't know. So those things are the gray areas which we try to validate. And also when we try to validate things, that times new problems will be uncovered. Okay, that problems we try to resolve,
Okay,
right? Yeah. So, and auto scaling, as you clearly pointed out, that's exactly a good point because auto scaling is a scenario in chaos engineering. Okay, we test auto scaling horizontal, vertical. We try to validate the auto scaling, and it's very easy to do it using chaos tools because let's say in performance, if you're adding traffic and you're hitting the CPU utilizations of different values, and when you're doing it, it's very slow. Okay, that way. But when you're doing using chaos tools, it's very quick, like you can bring your CPU and memory to whatever value you want in just a matter of time. Okay, and that way you can test auto scaling very easily. So that's all that scenarios we will see. Okay, in the course, like how it happens and how you test it in live. We will see what's that,
okay,
right? Now just to this is now the AWS dashboard. Okay, when you create an account, a free trial or any account, when you land on the AWS dashboard, you will see this. If you haven't visited anywhere, the recently visited will be empty. But I have gone in my account, so that's why you're seeing all this. Okay. Now, if I go to EC2, just enter EC2. This will open this. So in this, click on EC2. Okay. Now here, just scroll down. There will be a section called launch instance. Just click on launch instance. Now this is optional. Okay, now all of you should if you are not interested also, you no need to do this hands-on. It's optional thing because it's on AWS. Again, you need to create a free trial and all. But yeah, those who are interested, they can do it. Okay, so chaos demo. So here you are giving a name to that instance, okay, whichever instance I'm creating. So what do I mean by instance is just a CPU RAM, okay, on cloud. So cloud doesn't mean that there are some, it's not a very different thing. It's more sort of like your laptop only, okay. So cloud is more sort of, there are a lot of CPU sitting somewhere, and those CPUs are connected to the network, okay, and you can utilize those CPUs as you want. Okay, so that's what the cloud is. So cloud is not like something like it's like a continuous thing, like lot of CPU, lot of memory sitting somewhere. No, they are like separate CPUs only. Okay, and you can just use it as you wish. Like for example, even you can take the CPUs what are there. Okay, you can divide the CPU into like 5 parts. You can use one of that part also. Okay, in that way also you can use. That's a thing of cloud. Okay, so just consider it like a, in the instance means like a CPU. Okay, I'm just like let's say for my laptop, this one. So I have CPU, right? I have CPU of 4 core, okay, and this is the base speed and all. This is the properties of the CPU. So mainly in CPU, when we see the cores. So more higher cores it has, more faster it is, okay, in processing the request. Memory again we have GB, like how the RAM, right? How much GB of memory we have. So we need to choose that instance, okay. So what like we are, that's what we are doing now. Okay, so I have given a name to that instance. Then what operating system I need to run in that instance? So like let's say I launch it using Ubuntu 18. Okay, then just instance type. So instance type is where we choose what's the CPU and memory. Okay, so there are different types with different like for example T2 micro, if you see, it is 1 V core, 1 GB memory. Okay, and if you see, if you scroll down, T2 small is 1 V core, 2 GB memory. Now can I choose any machine, or so what I need to consider before I choose a machine? What's the major thing? What do you think?
Cost of the machine and what is the requirement?
Exactly. Okay. So see, now if you can see it clearly, if it's a Linux machine, it is saying $0.012 per hour. Okay. If I go to T2 small, that has increased. See, 0.05 user dollars per hour, USD per hour, right? So based on what machine you choose, okay, your cost will increase. Now T2 micro is generally free. Like you can get one T2 micro free for an account. Okay, one account you get it free. If you go to T2 small and all, it is not free, it is paid. Okay, so be careful when you create these machines. T2 micro is free, so you can do that, but other things are paid. So whenever you are doing anything on cloud, make sure that it is free. Okay, because what happens is everything whatever you touch on cloud is pay per use. Okay, so even the IP, even any small things. Okay, so be careful whenever you are doing anything that it is free. Okay, if you do whatever I am doing, yeah, so that's what. So you should be very careful, okay, whether it's free. So yeah, so I will choose T2 medium, okay, which is 2 V core 4 GB memory and key pair. So now this is where you can create either a PPK file or a PPM, where we call it for connecting, like it's a key pair. Okay, so I will use already which I already have, just to have it easy, but you can create a new key pair also. If you click on this, it will ask for the key pair name, and you can give whether it is PEM file or a PPK which you want, and just click on create key pair. So that will get downloaded. So the public key will the private key will get downloaded. Okay, so once you have that, what will happen is you can connect using SSH and all. Okay, using that key pair. So I already have one in my machine, I have downloaded, and that one I will use. Okay, now coming down, you can create a security group, basically what ports you want to open and all those, the firewalls. Okay, the firewall settings, that's what you give here. So what I will do is I will use just I will select this allow options here. Okay, SSH and all. So again, I will choose one which is already there. I will show you what are the settings I have used there, which I launch the security group. Okay, and then coming down, the final is the disk, like how much storage you want, 8 GB, and what type of disk you want. Like the type of disk means the read write of that disk will be different for each, and the cost will be different. GP2, GP3 is faster than GP2. Okay, so that way it's an SSD. So you need to choose what you want. So let's say I choose, let's say 10 GB. Okay. And once I choose all this, what I will do is I will just click launch instance. Okay, so you'll get a message successfully initiated launch of instance. Now, if I click on this link here, it will take me to this instance here. So I have, so this is the instance and it is still in the pending state. It will come up in some time. Okay, so let's wait for that. Right. So now it's in the running state. So what I will do now, just copy this public IP. So using this IP only you will connect to this machine. Okay. So just copy this public IP. What I did is just I went into that instance. Okay. Just click on this. Okay. And I went here. So here you can see all the details regarding that machine. Even you scroll down, if you see, I have the details and the machine image and all what it used and all those. Then the security, if you go, I can see the security group, what I chose, right? So what all ports I have opened and all. So for example, for this one, I have opened this, like I have kept all the ports open because so that we avoid any port issues, okay? But it's not a standard way to do it. Since it's a demo, I have done it, but you should not open all the ports. Okay, you have to keep only those ports you want, which is you need to keep those open. We'll see what's the significance of 80 port, 443 port and all as we progress. Okay, so security group what I chose basically is for this, for opening the ports for that machine. And yeah, so just to give let's copy this public IP. Okay, just copy it. Now open the tool called putty. Putty you can easily download. Just go to Putty. You type Putty download. You can directly go to this application here and you can click download Putty. That's all. Okay. And you can install it. It's very easy. Once you install Putty and you open Putty, the software will look something like this. Okay. Here you put your public IP. This one you put it, and port you should keep 22 because it's a SSH port. Okay. Keep it 22. Now come down to SSH here, auth, credentials. So SSH, auth, credentials. Now here you need to choose that file which you downloaded, the PPK file. No, you need to browse and choose that file. Okay. So whatever you downloaded, that file, this one, right? You need to put it. You can need to browse and put it here. Once you do that, then click open. Give accept. And here username is generally always Ubuntu. Just give login as Ubuntu. By the default, it gives Ubuntu as a username. So now basically what you have done is you are inside that machine now. This is the terminal of that machine. Okay. So uh, it's more sort of, see, now this is more sort of like your own laptop machine only. Only thing is you don't have a GUI. Okay, like GUI means like you don't have these icons and all. That GUI is not set up. Otherwise, it's the same like your laptop. Now you can do whatever installation, everything what you want to do on this machine, and you know what's this machine, RAM, CPU which we chose, right? Those will come here. Is it clear, everyone? What's an instance now? Anyone having any doubt regarding that? Because I have seen like some people still have that doubt, like what's an instance? It's similar to our laptop only, like our machine, right?
Yeah, Vishnu, it's about the connecting. Is it really mandated to use Putty, or can we connect using the connect option in the AWS console?
Any, but
Oh,
only thing is Ubuntu 18 if you use, no, you don't have that connect
mhm.
option here. You have to
Okay.
use version 22 or some. So basically, why I showed you the putty is it's a general way. Okay, like it irrespective of what OS you use. But if you want to use the connect here using the AWS, you need to use version 22 Ubuntu versions. Then
Mhm.
only you can
Okay.
connect using like this. Yeah. Yeah. Okay. So now we are inside this. So what we will do quickly is let's set up this host on Gremlin. So today, since like the time is almost getting over, I will just quickly show you, okay, and then we will come back on the real detail of how the setup was done. But I'll just show you quickly. Okay, so that you get the um, like just a feel of what is happening. Okay, right. So now, so currently, see, when you don't have any agents installed on Gremlin, as soon as you land on the dashboard of Gremlin, right, you will see the options of installation on different machines. Okay, so currently we have Ubuntu. So first, what we will do is we will copy this command. First, we will go root, okay, because so that we don't face any access issues. So to go root, you enter sudo -i, okay, then paste this command here. So initially what we are doing is we are adding the Gremlin repo, okay, using the apt, okay. So we are using apt repositories for installing Gremlin, okay. It's for Ubuntu. So just we are adding this repository, okay. So you will get the message release non-free has been added, okay. Basically it's added, okay. Now we will import the GPG key. GPG key is nothing but a privacy guard key, we call it. Privacy guard key is nothing but every software which maybe in future past also when you are installed you would have seen this GPG word, okay, or the GPG key. So what it happens is, see, now your Gremlin is communicating with your machine, right? So to make that communication channel secure, there's a key transfer which will happen between each other, okay, so that if anyone tries to intrude in between also, the key will not match, and the Gremlin or the host will not allow the request to come and go, okay. So that's why we are adding a GPG.
It's similar to Masal connection, Vishnu.
Yeah, we can say similar, but it's called a privacy guard key. It's more sort of guarding our data, the privacy data.
Okay.
Okay. So yeah, so you will get a message GPG has been imported. Okay. Once it's done, what we will do is we will install the Gremlin client and daemon, which is very important. Okay. Now this is the point where we are installing the Gremlin and the Gremlin daemon. So now if you see, just remember these, okay, we don't have any agents installed currently, okay. So now that's what we are doing now. We are installing the agent, okay, onto our machine. And also it's a very simple machine. There's no application running on this machine. So we are just seeing how we set up a Gremlin on a host, a basic host, okay. Things will become complex as we go, like as we move on with like slowly. Okay, so now this is the basic thing, like what we do initial fundamentally. Okay, we'll try to understand that. Right. So once you are done with this, what we need to do is, now this is a very important step next. Okay. We need to initialize Gremlin. Okay. So that step they will not mention it here. Okay. So once you do that, you need to initialize Gremlin. So how do we do that? Okay. So that's what we are going to see next. So to do that, we need two things. One is a team ID and team secret. Okay. So go to team settings, go to configuration. There you can find your team ID. Okay, just copy this team ID and keep it somewhere. Okay, let me open. Yeah, so yeah, let's keep it here. Okay, so team ID we have it. Okay, similarly we will have the secret key also. Now the secret key can be created only once, so we need to be careful when we create the secret key, because if you reset it, all the agents or all whoever are using it will be gone. Okay, so secret key has to be very careful. We have to be very careful when we do this. So that's why I have kept it. I have copied and kept it here. So let me open that. Anyways, let me do one thing. Right, so this is my secret key which I have generated, and this is my team ID, and this only your team admin can create. Okay, the secret key, all cannot do that. So it can be only created once. Okay, so and team ID is your team, it's a common for your team. So now what we will do is just enter gremlin init here. Okay, so once you enter gremlin init, gremlin space init, it will ask you for your team ID. Okay, so just copy the team ID which you copied and paste it here and give enter. Now next it will ask for the team secret. So team secret is very important because when you paste it, you won't be seeing it. Okay, so don't paste it twice. If you paste it twice, you will get the error. Okay, so just paste it only once, just one click. Okay, it's pasted. Okay, it will not be visible in front of you. Be careful. Okay, then give enter. Okay, so you will see using for team ID, using for Gremlin identifier. Basically, it's done. Now to check whether the installation was proper or not, just enter Gremlin check. Okay, automatically it will print out some logs for you. Now here you need to look, the main log is this one, the auth. Okay, the auth here you should see API response. Okay, this is very important. Okay, the next is this one, daemon. This daemon version you should see. If you don't see that also, there's a problem. Okay, once you do that, just go back to Gremlin. Okay, now if I go to agents, are you seeing on agent now active? Now how will I know whether this is the agent which my agent? Okay, so if you see here, what's the IP of my agent? It is 172.31.44.36, the local IP. So 172.31.44.36, right? It is same machine. So our agent is now installed. It's active. Now what we can do, we can just check if our configuration is all proper, running some sanity experiment on it. So what I will do is just go to experiment. I'll explain you all this, okay, again, but this is just for showing you, okay. So just go to new experiment. I will just run a CPU, basic CPU attack, okay. And I will choose the host. Since we have only one host, I will choose target all hosts. Only one host we have. I'll explain you all this later as we progress, what these are. Then I'll go to a resource attack. I'll run a CPU attack. Let's say I make the CPU capacity to 80 and I'll target all cores and let's run it for length 60 seconds and click run. If our configuration is proper, our test should run. So let's see if that is happening. At the same time, we will just enter a stop to see whether the percentage is increasing. So what's the CPU percentage now you're seeing? Everyone, what are you seeing the
It's
percentage?
159, 160.
160%, because it's a two core machine, okay, and we chose all core, right? Attack all cores with 80%. So how many cores you have? 80 into that many cores, okay, 80 into 2, so 160%. That's what you're seeing here. And if you see separately also, it is there, see 80. So our attack is running properly, okay. So now once I stop my attack, okay, let's say I stop my attack. Now my attack is running, okay. So what I do is I'll stop the attack. I'll click on halt. So basically I had given it for 1 minute. So after 1 minute also it would have stopped automatically. Okay. But let's say I stop it manually. Okay. Now if I go back and see what's the CPU percentage now, is it back
It's
to
close
normal?
to
Yeah,
zero.
back to
Yeah.
normal, yes.
Exactly. So that's the beauty of again Gremlin. Okay. So whenever you run any attack, it will properly clean everything before it leaves also. Okay. But other open source tools don't have this problem. Like they have some problem. Like they don't do the cleaning process very easily or very clearly. Okay. They will leave something behind, and that will create some issues. But Gremlin has a proper cleaning mechanism. So once your attack is done, it will not leave anything of like anything back which is related to its attack. Okay, Only thing what will remain is your system issues. Obviously, maybe system will get stuck in that loop or somewhere. That is a different issue. But the gremlin related stuff will not be there. Okay, it will clean everything before we halt or we stop the experiment. Okay, when we do that. Yeah, right. So just wanted to showcase like how the Gremlin works and how you run an attack. So there are various different attacks, 12 different attacks are there, which we will see, and which are the major ones, major types of attacks which we have. One slowly, when we go further, we will try to understand all those attacks one by one, where it's used, what are the target systems we use it on, and all those we will try to see. Any questions, anyone?
In
Vishnu,
the
this
Gremlin,
is Nandan. Yeah, Krishna, go ahead.
Yeah,
yeah,
yeah, Nandan.
so that IP address is there, right? Uh, is it possible to rename to the host name like Chaos Demo in the Gremlin UI?
The agent you are saying, Krishna?
Yeah, yeah,
Yeah, so there is an option, but it is you need to do it when you are deploying it. But generally, we don't do that. We keep it the public, the local IP only, because that's unique, right, for each machine.
yeah,
So
yeah.
yeah, so that's why we don't change it. Yes.
Oh,
Uh, Yeah, Vishnu, I have a question. Like, in case of we are talking about cloud, right? So, in case if we have a serverless architecture, so in that case, how would we try to attack the system? Because will not have any things like IPs and all, right?
Same. Okay, so there is no much of a difference. If though if you have a serverless system also, Gremlin, we will see that. Okay, as we progress,
Okay,
I will explain you if you have a serverless systems, what you need to do. Like how to implement Gremlin.
okay,
Yeah,
okay.
Vishnu,
And
one
because
also,
what
question.
there no, in that case you need to first consider few steps, like what's a cloud provider. Okay, like for example, some AWS Lambda or some, okay, I don't know, like what you will be using, what's cloud like AWS, what cloud
we are
provider it
using
is.
GCP, GCP
Yeah,
based.
so then you set up a Gremlin account, then the configurations, it's you can be it can be done. Okay, not a big deal.
Okay.
Yeah, it's similar to what we do. Yes, go ahead.
Uh,
Someone was asking some question,
Yeah,
right?
Vishnu, yeah, a very basic question. We need to have Gremlin account, right? I can see it is for 30-day trial version. Then how can we extend it further?
No, we cannot. That's why I said, like, I will give you my the Gremlin account organization license for 1 month. Okay, so you can use that. After that, you will have to, yeah, like it's based on you. You'll have to live with the free trial, or else you will have to buy.
Okay.
Yeah. So, anyways, I will be giving you for one, so you can play around with the organization version, enterprise version, how it will be like full functionalities. You can utilize it, like not only 1 month, even when you require, you can ask me. I can provide you for POC and all, for maybe 1 week again in between. You need always, you can always ping me. I can provide you the access. Only thing is, I
Thank.
just keep deleting the users so that I don't keep bulking up with lot of
Yeah,
users, because so many batches coming and going, right? So
yeah, understood.
yeah,
You have told.
yeah.
Yeah, thanks.
Uh, One more thing, Vishnu. So on a different note, like I have regular issues. I just want to know, like,
Nandan, sorry,
so
your voice is breaking. Is it from my end, some problem?
It's for
uh,
me also.
Yeah, yeah.
yeah, do you hear me
Nandan,
now?
can you? Yeah, yeah, yes, yes.
Yeah, I have one peculiar issue like currently, so I just want to ask you. So we are using a PCF Pivotal Cloud Foundry as for some of the microservices. So currently there is a criteria of CPU entitlement in that particular systems. So whenever they have given it as a hard-coded value, like based on the memory. So I just want to understand, like by using chaos tools, so can we come to a conclusion that this can be the CPU entitlement for this particular system?
Yeah, so that's a good question. See, what happens is if you want to configure that, like if you want to study that, like what's the correct value for that, you can set up an experiment. What you can do is you can monitor your CPU entitlement. then you can do some CPU and memory attacks, and you can study that. Based on that, you can come into a conclusion like what's the correct value for that. Yes.
Yeah, currently what we have is like they have given hard-coded values, but I feel like that is not exact. Like I want some evidence based on data, so that's the reason I have asked. Like, can we get any evidence from the data once we do some case tools testing?
You can, but obviously you should have a proper observability setup like the monitoring. Okay, all the events and everything has to be collected properly. Then you can obviously do, okay, like you can increase the CPU load, or even the resource contention. Okay, then how your SPCF environment response you can study. Okay, so but
Okay,
obviously you should have a monitoring tool. Without that you cannot. Okay, because
okay.
directly Gremlin will not provide you any monitoring abilities as such. So any
Yeah,
Grafana or
we
some
have
other.
monitoring tools.
Yeah.
Yeah.
Mm. Yeah. Right. So I have one small hard stop now. Any other questions? Quick, maybe I'll take one question or.
One quick question, Vishnu. So, whatever you showed, that is the I assume it is a pre-built experiment, right? So we don't need to target any application. So for to target those applications, that configuration and setup will be separate for the Gremlin, right?
Yeah, so that's what we will see, right? We will take a demo application, we will deploy a Kubernetes cluster based application onto our machines, and then we will set up Gremlin onto that. So that will
Okay,
make you understand how we do that, right? Yeah.
okay, got it.
So this is basically to show you like how the Gremlin attacks happen, and how you observe that in your machine. Okay, just to give
Mhm.
you a brief overview, I showed this, and it's a very starting point. Okay, as you progress, you will go to Docker, containers, Kubernetes. So for every system, it's a different way of installation implementation. It's not very straightforward as. So there are, but you can easily classify into three types of system. One is host, one is containers, and one is Kubernetes. So all the world will fit inside that.
So where can we find all these recordings, Vishnu?
You will get in the YouTube. You will get the playlist link. Okay, so once you start, once you join the final sessions, right? You will get your private. Like they will add you to the YouTube private channel. So there you will find the videos. Yeah.
So Vishnu, the timings will be 7:30 to 8:30. Is there any other batch you are planning? Because this is not suitable for me, but
Okay. Where are you currently, Veera, located?
I mean Hyderabad only. But generally, I go to office at 7:30 to just to avoid the chaos, traffic chaos.
Mm. Yeah, so currently we have only this timing batch. Uh, yeah, so because why 7:30 we have chosen is it's for considering the office timings only. Because generally by 9 people go to the office. So, uh, but yeah, you are very early. So,
Yeah, yeah,
okay.
that's okay. Maybe few days I will manage.
Otherwise, what you can do is you can pick up the call from office. Anyways, it's upskilling only, right? So I don't think it will be a problem.
But the travel time is between 7:30 to 8:30. So I'll
Oh,
reach by 8:30. So then,
okay.
yeah,
Hmm.
that's okay. I will manage. Maybe I will start late, 11:30 something. So,
Yeah, yeah, yeah.
okay.
Because this is from analysis only, like generally the requests come for 7:30 more people. So considering all those, only we have kept this time.
Okay.
Yeah,
Understood.
yeah. Okay, then, yeah. Then thank you all, and have a good day. Meet you tomorrow. Thank you.
Yeah. See you. Bye.
Thanks, Vishnu. Have a great day.